Hi, in this video we are going to see about a Python project which is entitled as Traffic Sign Classification using Deep Learning, which is an IEEE 2023 conference paper. Before seeing the execution of the project, let me brief about this project. So due to the advancement of artificial intelligence, the self-driving vehicles are increasing a lot of attentions and improvements. One of the important feature of the self-driving vehicles is the capability or capacity to identify the traffic signs that is available in the roadsides. So this is to have the safety and security of the passengers for both inside and outside the vehicle. So the identifying the traffic sign and classifying the traffic signs is the main objective of the paper. In the base paper, the authors have used the CNN, convolutional neural network model, for this traffic sign classification, and they have achieved the accuracy of 95.8%. So now let us see about the proposed system. So kindly note that we are not going to use the same as mentioned in the base paper. So we have improved the base paper concept and also we have made some enhancements in it. So now let us see about those things. So we are going to use two different models in our proposed system. The first model using the MobileNet architecture, and the training accuracy that we have achieved is 97%, and the validation accuracy we have achieved is 98%. And the second model that we have used is YOLOv5. So here for the first model using the MobileNet architecture, we'll be giving the input image and it will be finding the traffic sign which class it belongs to. And in YOLOv5 also we have the same option, and additionally we are going to use a real-time concept here. So real-time means using a web camera it is going to predict it. So now let us see the abstract of the project. So here you can see the IEEE base paper title, that is traffic sign classification using deep learning, or you can use a proposed title, that is real-time traffic sign recognition and classification with the deep learning. So this is the IEEE base paper abstract. So coming to our proposed abstract. So here we are going to use the Python and two distinctive models, that is MobileNet architecture and YOLOv5. So here in the MobileNet architecture, as mentioned, we achieved the accuracy of 97 of training percentage and validation accuracy of 98%. And coming to the data set part, so here in the MobileNet architecture we will be using 4170 images. And also importantly, you can see the classes that we have used is 58 traffic sign classes. So I'll show you the data set part right now. So in the model we have the MobileNet model in the data set part. So here you can see the traffic data. So here you can see all the 58 classes. So I'll show you one by one. So here you can see the class 0, class 1. So in this way you can see which contains around 58 classes with various traffic signs. So and here you can see the annotations of it. So in the data set we can see the labels. So here you can see what are all the traffic signs that we are going to use. So 58 classes contain the speed limit of 5 km, 15 km, 30, 40, 50, 60, 70, 80. Don't go straight or left, don't go straight or right. Don't go straight, don't go left, don't go left or right, don't go right, don't overtake from left, you don't, no car, no horn, speed limit 40, speed limit 50, go straight or right, go straight. So in this way it is considered which has around 58 classes. Now second thing is the YOLOv5. So in the YOLOv5, as mentioned, we'll be using two things, that is using the image data and also real-time web camera. So you need to have the web camera connected when you are executing the project. I'll show you that one. So here we have 38 traffic sign classes. So here we'll be using different dataset model. So here in the YOLOv5, if we go to dataset part, so here you can see the test, train and validation folder. So in the train you can see the images. So here you can see the various traffic signs. So here you can see the various classes. I will show you what are the classes that we have available. So I'll scroll down and show you all the images. So here you can see the YOLO v5 part, the training data folder contains 1392 images, and in the test images we have around 173 images, and in the validation part images we have around 173 images. So this is all different data set than the MobileNet architecture. So here in the YOLO v5 we have the data set, and also here you can see the labels that is used for the YOLO v5 part, which contains the 39 traffic signs like pedestrian, left sharp curve, right sharp curve, no overtaking, turn left, turn right, speed limit 70, 50, 30, 20, 60, no waiting, road work, traffic sign, snow warning sign, slippery road, giveaway, roundabout, no stopping, go straight. So these kinds of things are available in the YOLO part. Now coming back to the abstract document, so here you can see the summary of the abstract, and also coming to the existing system. So here we are considering the base paper as existing system. So base paper, they have used CNN, convolution neural network, and they have mentioned that they have achieved the accuracy of 95.8%, but we have achieved accuracy of 97 as training, and validation is of 98. So we have improved the accuracy, and also we have improved the model by 2 different models, and also we improved the classes. So in the traffic sign, they have classes, we have used more classes than the existing system, and also we have used the real-time web camera than the images also. So these are the various improvements that we have done from the base paper part. So here you can see the existing system details, and coming to the disadvantages, we have listed the disadvantages like less accuracy, less class coverage, less real-time capability. All these things are being listed out here in the disadvantage of the existing system. Coming to the proposed system, as mentioned, we are using the MobileNet and YOLO v5 part in it, and also here you can see the details of that proposed system, which contains the MobileNet achieved the accuracy of 97% and validation is 98%. The data set contains 4170 images and 58 classes. So 58 classes images, what are the classes, all the things that is mentioned here. And in the YOLO also we have used 39 classes, all the classes of the traffic signs is mentioned here in the proposed system detailedly, and we have concluded with the proposed system, which made the improvement from the existing system. And here we have listed the advantages of the proposed system. So these are the advantages of our proposed system model. And coming to the system architecture, you can see the 2 different models. So that is traffic sign image data set is given because both are having different data sets. So that is the reason we have splitted here. And also here you can see the MobileNet architecture and YOLOv5, and the printed result is shows the traffic sign, and also we have used the performance analysis and chart part. So here you can see the system requirements, which contains the hardware requirements. So here you can see the web camera, because this project requires a web camera. And software requirements, as mentioned, we'll be using Python. The version that we are using is Python 3.10.9. The web framework is Flask. The front end part, we have used the HTML, CSS and JavaScript, and this is the reference of the project. This is the base paper reference of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python and the libraries installed in your system. So now let us see the execution of the project. So first copy the source code location. Now go to your command prompt. Now go to the drive location where you have pasted the code. In my case, I have pasted the code in F drive. So let me go to the F drive first. So now type cd space and then paste the location that we have copied and click enter. So now we are into the source code location. Now type python app.py and click enter, and kindly wait for a few minutes. So now you can see the URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, and just paste the URL that we have copied and click enter. And now you can see the home screen or welcome screen of the project with the project title, traffic sign classification using deep learning. So first you can see this login menu. Just click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and admin, and then click this login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part. So first we are going to see about the MobileNet architecture part. So as I said, there are two different parts, two different models, and using the image and also the live webcam option. So let me show you the YOLOv5 at last. So first thing is like we're going to see about the MobileNet architecture right now. So first let me select the preview image. So you can choose the image that is used in the test folder or in the train folder that we have used to train the model. So let me go to the source code folder first. So here you can see the test data folder where we have given you the two folders, MobileNet model test data folder and VNet YOLOv5 test data folder. So let me go to the MobileNet. So here you can see all the classes that we have mentioned. So in the MobileNet architecture, as I said, there are 58 traffic sign classes. So all the things have been given. So let me show you one by one quickly. Let me go to the first one, bicycle crossing, and let me select an image and then click submit. So now you can see the image that I have selected, and also the prediction result is bicycle crossing. So once if you wanted to check with other case, you can just click this preview menu so that it will be navigated to the preview page and you can select the image. And here comes another question to you, that what happens if you are selecting some other image, for example if your face image or an animal image, or if it is an object, some other image like that. So here it's, if you're giving some other image, it gives some random result only, because we cannot train up the system or the model with all the images that is available in the world. So we cannot do like that, because this model becomes, I cannot say it cannot be done, it can be done, but it is like the model becomes very big, so it is not possible for a short duration of time. So now let me select a second case image. Let me go to the test folder again. I'll just select from this folder. Let me select an image from this and let me click submit. And now you can see the prediction result is children crossing sign. And let me go to the preview menu. Let me select an image and then click submit. And now you can see it is treated as danger ahead correctly. And let me go to the preview menu again. I'll just make it quickly because there are various classes, so that the video length may not go longer. So let me select this image and then click submit. Now you can see the predicted result is dangerous curve to the left. We go to the preview menu, select, then let me go to this folder and select and then click submit. Now you can see the dangerous curve to the right has been predicted correctly. And let me go to the don't go left folder and then select submit. Now you can see the predicted result is don't go left, traffic sign is predicted correctly. We go to the next folder and select an image randomly. Now you can see it is selected as don't go left or right image correctly. We go to the next one. We select an image and give submit. Now you can see it is predicted correctly as don't go right. Go to the preview menu. Next folder, select an image and click submit. So now you can see the predicted result is don't go straight is predicted correctly. Go to the preview menu. Select an image and click submit. So now you can see the predicted result is don't go straight or left. Go to the preview menu again. Go to the next one. So you can see the predicted result is don't go straight or right. Go to the preview menu. Go to the next class, select an image, click submit. So now you can see the predicted result is don't overtake from left. Go to the preview menu. Now let me go to the next one and select an image and click submit. Now you can see the predicted result is fences traffic sign. Go to the preview menu. Go to the next one. see the picture result is give way traffic sign. We go to the preview menu again. We select the next one, click submit. Now you can see the picture result is go left. We select the next case. So the picture result is go left or right. See the picture result is go left or straight. Let me check for the result for this, and you can see the picture result is go right. It's printed correctly. Now you can see the picture result is go right or straight is printed correctly. For the next one, let me select the image and click submit. Now you can see the picture result is go straight. Let me select this one and click submit. Now you can see the picture result is go straight or right. We go to the preview menu again. Let me select an image and click submit. And now you can see the picture result is heavy vehicle accidents traffic sign. For this case, it is printed as on correctly. For the next one, so now it is printed correctly. Speed limit 5 km/h traffic sign. Let me show you final, because if I'm going to say all the things, it takes more time, the video length will be more. So you can check with other cases. I'll show you final one with this image and click submit. Now you can see the picture result is train crossing. So in this way you can check with all the 58 traffic sign classes we have given you. And to make the video shorter, I'll go to the next part, the performance analysis part. So this is the performance analysis of the first part, that is the MobileNet architecture. So the performance analysis parameters contain the accuracy, precision, recall and F measure value. So accuracy is 0.98, precision is 1.00, recall is 0.98, F measure value is 0.98. And go to the chart part. So this is a chart. This is a static chart only. This is not a dynamic chart because we are not used any database in the project as mentioned earlier. So this chart contains the model loss and model accuracy graph. So the model loss graph is contains the loss and epochs, and model accuracy graph contains the accuracy and the epochs of the model that we have developed. So this is being depicted from the backend code, model code that we have developed. So this chart part contains the model loss and model accuracy graph of the MobileNet architecture. And now coming to the YOLOv5 part. So just click this YOLOv5 prediction. So it will be navigated to the YOLOv5 prediction part. So in the YOLOv5 part, again we have two different subdivisions. That is one using the single image and the live detection. I'll show you both the thing. So just select this choose image folder, first one for the image part. So this time you need to go to the YOLOv5 test data, because as I said, we are using different data sets for the both the models, MobileNet architecture and YOLOv5. So in the YOLOv5 we have 39 unique traffic sign classes. So let me go to this folder and let me select an image first and then click this image. I have selected single image and then click submit. So now you can see the YOLOv5 is making a mark of the traffic sign, and also it is showing the speed limit as 30, and here you can see the percentage, that is the accuracy percentage. It is what is the level of the prediction level. So that is, it is showing that 84% of it. So let me go to the prediction YOLOv5 prediction menu again to check with other case. So now let me select an image and Let me go for some other case right now. I'll just select this one and let submit. So now you can see it does not printed anything. I'll just refresh it. This is the image I selected. I'll just select it again and image and then click submit. So this image is not printed correctly. So now let me go to the next one and show you. Let me select this one and then click submit. So now let me choose another image. Let me select this image and then click submit. So now you can see it is printed as speed limit 50. It has been marked again. And now let me go to the YOLOv5 prediction, and now let me select an image from the other case. This time I'll just go for this one and click submit. So now you can see it is printed as speed limit 100. And now let me click the UV prediction part, and now let me select another image and then click submit. So now you can see it is marking the traffic sign, and also it is showing the left sharp traffic sign in it. So in this way you can check with the other images. So the two images it is not printed correctly, that is there is no entry, and this one, so it has predicting other case. So now let me check with a final image. Let me check with this image and then click submit. So now you can see it has correctly marked the traffic sign, also it is showing the left sharp curve. Now let me go to the important part, that is using the live web camera. So before doing this, make sure that you are connected the web camera in your PC. In case if you're running in PC or in your laptop, make sure that you are having the web camera is working correctly or not. So now let me connect the web camera and let me select the live detection. And now let me make the screen in the two parts, so that in other part I will just open the images and then find it out. So now let me go to the test data folder, YOLOv5, and let me open this image. So now let me submit and click the live detection part. So now my web camera is turned on. So now let me make the screen in two parts and show you. So now you can see the left side is the image and the right side is the window of our project. So here you can see when I am showing this, it detects the speed limit 30 correctly. Now let me close this. Now let me select another one. So now you can see it is predicting the traffic sign correctly as traffic speed limit 50. Let me open some other image. Now you can see the speed limit 70 sign is recognized correctly. So now you can see it is correctly printing as speed limit 80. So now you can see it is printed correctly as turn left. So now you can see it is printing other traffic sign. There are two traffic signs, so it is printing the backside one as no waiting. Now you can see it is printing correctly as speed limit 120. So this way you can check with all the images that is available in the test and train folder of the YOLO. So in this way you can check with the real-time web camera option here. So now let me come back. So in this way, in the YOLO part you can check with the image and the live reduction part. Now let me log out. And this is all about the project traffic sign classification using deep learning using Python. And thank you for watching.